This is your recap for chapters 6, 7, and 8, the skeletal system. For this test, you'll be able to use one sheet of paper, single-sided. We talked about the skeletal system in 3 sections. We really focused on osseous tissue, and then we went into what bones belong to the axial and appendicular skeletons. And remember, your skeletal system does not only include the 206 bones of your skeleton, but it also includes cartilage, ligaments, and other connective tissues. We took a look at the functions being support, storage of minerals. When we're talking about mineral storage, calcium is the most abundant mineral in your body. And we also can store energy in our yellow bone marrow. It helps us produce red blood cells through our red bone marrow, protects our vital organs, and helps us produce movements. Be familiar with the classification of bones. Which bones are classified by which shape? You have your long bones, like your humerus and your femur. You have flat bones, like the bones of your skull, your parietal, temporal, occipital, frontal. You have sutural bones, which are the lines that are holding your bones of your skull together. Irregular bones, like your vertebrae and your pelvis. Short bones is one that people get confused a lot. Your short bones are like your carpals and your tarsals. And then an example of a sesamoid bone is your patella. We then went into talking about the anatomy of bones, and we took a look at how long bones are structured. The ends of your long bones are called the epiphysis. Within the epiphysis, that's where we're going to find spongy bone. The midsection of your bone is called the diaphysis. The diaphysis is made of compact bone. In between the epiphysis and the diaphysis is the metaphysis. And then inside the diaphysis, we find the medullary or the marrow cavity. We then took a look at how spongy bone, we call a spongy bone sandwich because it's going to have a layer of compact bone, spongy bone in the middle, followed by a bottom layer of compact bone. Bone histology, we took a look at what our compact bones are made of. So when we look at a picture of compact bone, they're structured in an osteon system, and osteons are just our basic units of bone. That's what looks like the tree trunks. Within our osteons, we're going to find lacunae, which are these little pockets that contain our osteocytes or our mature bone cells. Osteocytes are connected to one another by extensions called canaliculus. In the center of our osteon, we find the central canal, which is where blood vessels are. And then we'll get into bone coverings a little later. The bone cells, it's really important that you're able to differentiate between the different types of bone cells. Osteoprogenitor cells or osteogenic cells are your stem cells that we find in the inner layers of the periosteum and the endosteum. Those stem cells are going to help create osteoblasts. And osteoblasts are creating new bone. They're the ones that are making new bone matrix. Osteoblasts will mature into osteocytes. Osteocytes cannot divide, but they do maintain the structure of our bone. And then you have osteoclasts, which are our bone destroyers. They release enzymes that help break down bone. Take a look at this diagram if you need a little more explanation or the visual helps. We then went into a little more about how compact bone is structured. I think it's a lot easier to look at this picture. On that previous slide, it talked a lot about the lamellae. The lamellae are just the rings around that are forming our osteons, the layers of our osteons. So the lamellae are like what we would think about as our tree trunks. And there's 2 types. There's concentric, which are around the osteons. And then on the outside, we have circumferential lamellae that are surrounding the entire bone. This is a really great picture because it's showing you all the pieces of compact bone. And it also has a little bit of spongy bone in it as well. And spongy bone is structured a little differently because it has a system called trabeculae. Trabeculae is that kind of bridge-like red pattern that you can see in this picture. Within trabeculae, that's where we're going to find our red bone marrow. There are no osteocytes, there are osteocytes. What I meant to say is there are no osteons present. And then we looked at the 2 different types of bone marrow. You have red bone marrow, which is responsible for your blood cell production. We're going to find that within our spongy bone. And you have a yellow bone marrow that acts as an energy reserve that helps store fat, which we find in our marrow or medullary cavity. Your bone has two different coverings. It has a periosteum, which is the outside bone covering, and then the endosteum, which is on the inside. When we talked about bone growth, we looked at when our bones are growing normally, they go through a couple different processes. Calcification is when calcium salts are deposited. Endochondral ossification is what happens with our long bones. And endochondral ossification happens when we're replacing other tissues like cartilage with bone. There's two different types of growth you need to be familiar with. Interstitial, which means our bones are growing in length, and apositional, which means our bones are growing in width. Now, some flat bones, like the bones of your skull, are formed through intramembranous or dermal ossification. And then we looked at some different pathologies of what happens when bones grow where they're not supposed to. I would definitely be familiar with the steps of endochondral ossification. How do those long bones grow, starting with cartilage? You can, if this listing out the steps works good for you, that's awesome. You can also do it in picture form if you're a more visual learner. We talked about epiphyseal cartilage, which is your growth plate. When they're open, the bones are still growing. When they close, they turn into epiphyseal lines, which tells us the bone is done growing. We then looked at things that can increase our bone growth rates, like your diet, your exposure to the sun. Remember, when we're exposed to the sun, we make vitamin D, which in turn, through a long process, can get turned into calcium. Exercise or stress helps bones grow. When our bones are applied to stress, it creates these small electrical fields. And those electrical fields are going to attract osteoblasts, which help build our bones a little stronger. And then we talked about the hormones that are involved with bone growth. With bone pathologies, this is the one that you researched. Ones that I would be familiar with are giantism, which is where your pituitary hormone produces too much growth hormone. We have osteoporosis. In osteoporosis, you have more osteoclasts than osteoblasts, and it causes your bones to be filled with holes, which makes them really brittle and they break easily. Know the difference between a closed or a simple fracture, open or compound. Know that if it is an open fracture, the bone has gone through. If it's closed, the bone is still underneath the skin. We talked a little bit about bone repair after inflammation, and then we talked about the calcium levels in our blood. If your blood calcium levels are too low, cells in your parathyroid glands are going to release parathyroid hormone, or PTH. And what PTH does is it stimulates osteoclast activity, which causes our bones, the osteoclasts are going to start breaking down our bones, which is going to release calcium into our blood. It increases calcitrol release by the kidneys, which allows us to take in calcium in our small intestines. If your calcium levels are too high, parafollicular cells or your C cells in your thyroid release calcitonin. Calcitonin is going to stop osteoclast activity. We're going to stop that bone breakdown. It's going to cause a decreased calcium absorption in our small intestine and increases it in the kidneys. Here's some diagrams to help you with that. Then we looked at the axial skeleton. Remember, your axial skeleton only includes the bones of your skull, your vertebrae, and your rib cage. Everything else is going to be included in your appendicular skeleton, which includes the bones of your arms and their supporting structures like your clavicle and your scapula, and then the bones of your legs and their supporting structures like your pelvis. I think this diagram is a great way to keep them straight. A lot of people get confused on clavicle and scapula and pelvis. But that's all for chapter 6, 7, and 8, the skeletal system. Next up, we'll look at chapter 9, which is articulations. How do our joints create movement? Good luck studying!